Hi everyone. In the last video we talked about bar plots and histograms, and in this video we are going to talk about quartiles, median, and box plots, another way to display the distribution of data. So let's get started. So we're going to start with quartiles and the median, and then we're going to talk about box plots, and these things will kind of come at the same time. And then we're going to look at a bunch of examples to illustrate what these things are telling us. All right. So what I want to start with is just some data, and I've organized this data into what they call a dot plot. All right. So we have data values ranging from 1 all the way up to 30. And the dot plot, what it does is it shows a dot for every value. All right. Now some values have more than one dot, which means that that value occurred more than once in the data set. All right. So number 1 occurred once. That's why there's one dot above the number 1. The number 2 didn't appear at all in the data set, so there is no dot above the number 2. Number 3 occurred once. 4 occurred twice. That's why there's 2 dots. 5 occurred twice. 6 occurred 4 times. That's why there's 4 dots above 6, and etc. So this dot plot is kind of a nice graphical way of summarizing a data set. And it gives us a picture of the distribution, much like a bar graph or a histogram would. And in essence, it's doing the same thing. For each number, we're getting the frequency. Okay, but what we're going to do here is we're going to use this picture to get an idea of what quartiles and box plots are. Okay, so what we have first is we have the minimum value. That's the smallest data value in the data set. And so there it is. 1 is the minimum. Okay. Next, we can go to the lower 25% of the data. There are 36 dots here. There are 36 data values. So 25% of 36 is 9. So the first 9 dots, the first 9 data values constitute the lowest 25%. And the position of the number, the number where that bounds that lower 25%, that's called the first quartile. So 6 is the first quartile. It's also denoted Q1. Okay. Now let's find the second quartile. So how do we find the second quartile? We just go up another 25%. So there it is. I went up 9 more dots, and now I've got the first 50% of the data. This is exactly half the data to the left of the second quartile. Notice that the second quartile actually isn't a number in the data set. It actually falls exactly between 8 and 9. That's where we'd have to position ourselves to cut the data exactly in half. We have an even number of dots, 18 to the left and 18 to the right of this. So the quartiles don't actually have to be data values. They can fall in between data values, as is the case here. Next, we'll go over to another 25% of data. Let's see where that puts us. Right here. And again, we're falling between 12 and 13. So it's actually the third quartile, which has 75% of the data to its left, is 12.5, right between 12 and 13. And finally, we have the maximum value. So you see what the quartiles have done is they've split the data into 4 equal parts. Equal meaning there's an equal amount of data in each one of those parts. So there's 25% of the data between the minimum and Q1, 25% of the data between Q1 and Q2, 25% of the data between Q2 and Q3, and 25% of the data between Q3 and the maximum. And because it split the data into 4 parts, these 3 numbers split it into 4 parts, that's why we call them quartiles. Quarta is Latin for 4, right? So this is how the quartiles work. Now notice that just because they split the data into 4 equal parts, they are not equally spaced. That depends on the distribution of the data. But this is the magical thing about quartiles, is that when you plot them like this, it actually is showing you a picture, a depiction of the distribution of the data, right? By seeing how those quartiles are positioned, we get an idea of how the data is spread out. And then we're getting an idea of the distribution. So let's complete this picture. So what we're going to do is we're going to draw a box from Q1 to Q3. All right, so I'm going to move out of the way here. And let's get that box. So there's the box here. And now we have what's called a box plot. This is how you draw a box plot. You find Q1, Q2, Q3. We draw a box over there, and we draw these lines out to the min and the max. These lines out to the min and the max are called, adorably enough, they're called whiskers. Right? And that makes this the most adorable plot in all of statistics. It's the only one with whiskers. So this is how you make a box plot. We have to find these quartiles and then just draw this picture. Okay? So let's go through some examples. Actually, before I do this, I want to point out one more thing. I almost forgot. There's another important quantity that we can talk about. It's called the interquartile range. The interquartile range is the difference between Q3 and Q1. Take Q3 minus Q1. And the interquartile range is the width of the box part of the box plot. It's just telling you how wide the box is. It's also a measure of how spread out the data is on average. If the data were more spread out, the box would have been wider. And so the IQR would have been greater. If the data was more compressed, then the box would have been shorter and the IQR would have been smaller. So the IQR is giving us an idea of the, on average, how spread out the data is. Okay? So now let's look at some examples. Okay, so we're going to create box plots to represent these data sets. So here we have the systolic blood pressures of 7 men. Okay, so here we get some numbers. Now, to be able to find the quartiles to construct the box plot and to be able to find the min and the max, what we'll need to do here is organize the data from least to greatest. So that's the first step. Whenever you make a box plot, you should always sort the data from least to greatest. Otherwise, it's just going to be, you're going to get meaningless values. Okay? So here we go. We put the data in ascending order. So we just listed it out there. Okay, so now we can go make our box plot. So I'm going to experiment with something new here, a digital whiteboard, and we'll see how this works. So instead of writing on a piece of paper, I'm going to try doing it on the screen. So here we are. The systolic blood pressures sorted. I'm going to make my box plot. So remember what we start with. We start with the minimum. So let's find the minimum. The minimum value is the smallest value. That's 113. Okay? And we can also find the maximum. While we're at it, that's 170. Well, that was easy, right? Just the largest and the smallest and the largest value. Now, let's get going on these quartiles. Turns out the easiest quartile to find is the Q2, the second quartile. Okay, also called the median. Q2, also called the median. How do we find that? Well, think about what the quartiles do. They split the data into 4 equal parts. The Q2 is the second part. That splits the data in half. That means it has 50% of the data to its left and 50% of the data to its right. So that's the data value that's smack dab in the middle, right? So that is this one right over here. It's got exactly half the data to its left and half the data to its right. Now, let's find Q1. Q1 is the first quartile. It splits the first half of the data in half. If you take half of a half, you get a quarter. the first quartile. So I'm going to look at the data values to the left of the median, and I'm going to find the middle one of those. That's Q1. All right, and then let's get Q3. Q3 is the third quartile. That splits the second half of the data in half, right? So that, we look at this data here, and we find the middle number there. So Q3 is 151. So we found everything we need to make a box plot. Okay, so let's sketch it. I'll move off to the right a little bit, get some more space. All right, so let's look at these values. They go from 113 to 170. Why don't we just go from 100 to 170? And we'll start at 100, and we'll go off until we get to 170. So 110, 120, 130, 140, 150, 160, 170. 110, 120, 130, 140, 150, 160, 170. Oops, I see I'm in the way here. Oops, no, don't want to move that part. Okay. So let's go ahead and let me, sorry, I'm still learning how to use this thing. Bear with me. Can I move my, yes, I can kind of move it. I can move everything except the 100. Okay, let's move these things down. Just want a little more room here. There we go. Okay, let's draw it in a different color. Let's put some pizzazz in here. Okay, so the minimum is 113. Okay, so that is just a little bit. That's a third of the way between 110 and 120, right? So there's the 113. Then what's the next thing we encounter after the minimum? It's the first quartile, 124. So that's almost halfway. Oh my goodness. I am not good at drawing on this. Okay, there it is. 124. Then the next one is Q2, 132. And then Q3, 151. And then the maximum, 170. And we have our box going from Q1 to Q3, and we have our whisker going out to the maximum. And so there is our box plot. That's how you draw a box plot. Okay? Let's go to the next one. Here we have something about radish growth. Okay? Some radishes were growing, and they measured how much growth there was. Okay? Now this data is already sorted from least to greatest if we read from left to right and top to bottom. All right, so we don't have to worry about that step here. Let's go through and do what we did before. Let's find our min and our max. Those are the easiest things to find. They're just staring right at you. We'll find our Q2, or our median. We'll find Q1, and we'll find Q3. Okay? What's the minimum? It's the smallest value. What's the maximum? It's the largest value. Q2, it's the value in the middle. So let's see, what value is in the middle? How much data do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data points. So whatever's in the middle has 7 data points to its left and 7 data points to its right. So let's count off 7. 1, 2, 3, 4, 5, 6, 7. The middle is right here. All right? Notice that that falls between two numbers. It's not exactly on a number. If I picked 20, I'd have less data values to the left than I'd have to the right. And if I pick 22, I'd have more data values to the left than that I had to the right. Those wouldn't qualify as Q2. I need to find something that has an equal amount of data to the left and to the right. So I've got to go between 20 and 22. Okay, so what number is exactly midway between 20 and 22? It's 21. And by the way, a mathematical way of figuring that out, you do 20 plus 22 divided by 2. Right? That would get you 21. You just take the average of those two numbers. Okay, so that's Q2. What about Q1? Q1 is halfway between the minimum. Well, it's half. It's the, well, let's say it this way. It's the median of what's to the left of Q2, right? It's exactly what's in the middle to the left of Q2. So ignore everything to the right of Q2, and just look at all these numbers to the left of Q2. How many are there? There's 1, 2, 3, 4, 5, 6, 7, right? So which one is in the middle? Well, the fourth. The fourth will have 3 to the left and 3 to the right. All right? So take the fourth number, that's 15. Notice it's got 3 numbers to the left and 3 numbers to the right that are less than the median. So that is our Q1. Now what about Q3? Q3, we look at the numbers to the right of the median. So we've got 22, 25, 29, 30, 33, 35, and 37. Find the middle one. Which one's in the middle? It's exactly 30. 30 has 3 numbers to the left and 3 numbers to the right. So that's Q3. So this whole thing is just finding the middles. Every time we just find the middle. So it's as simple as that. We're just finding the middle of what's there. So let's look at the data values. It goes from 8 to 37. So let's just go from 0 to 40. Okay? So I'll draw my number line. 1, 2, 3, 4. 10, 20, 30, 40. Okay? And here we go. The first value we see is the 8. That's the minimum. The next value that comes in the list is the Q1, 15. The next value is Q2, that's 21. The next one is Q3, that's 30. And the last value is 37, the maximum. So we draw whiskers out to the min and the max, and we draw a box from Q1 to Q3. And that gives us our box plot. Okay? So sometimes the median will fall between two numbers. Sometimes the Q1 and Q3 will fall between two numbers. Sometimes they'll all will. Sometimes none of them will. It just depends on how much data there is. All right. So you always have to make that. You always have to be cautious of that. These values might be the values that fall between the numbers, not exactly on the numbers. Could happen with any of them. Okay. Okay, so I'm going to stop the video there, give you guys a breather. We'll pick up on this stuff and talk about how to interpret box plots in the next video. See you there.